Welcome to the Explainer. Today, we're unpacking a really massive shift in mobile technology. We're looking at how the upcoming Google Pixel 11 Pro is being engineered, from the absolute base silicon all the way up to the user interface, to be a true on-device AI powerhouse. We're talking about leaks, specs, and software roadmaps that show we're moving way past the era of your phone just being a dumb screen for cloud services. We're stepping right into the era of the autonomous agent. But before we get to the solution, we kind of have to understand the core problem, right? How do you actually fit a massive, large language model, literally an AI brain, into your pocket? Running these complex generative AI models usually requires giant server farms. If you try to force them onto a standard phone, you hit huge memory bottlenecks, your apps crash, and your battery basically melts. It's a logistical nightmare. So, how exactly is Google solving this for the Pixel 11 Pro?
Okay, let's dive into this. We're going to use a layer cake approach to uncover this tech stack. First up, the Pixel 11 Pro Vision. Then, Android 17 software upgrades. Third, the LiteRT AI engine. Fourth, shrinking AI with TurboQuant. And finally, number 5, the Edge AI experience. Layer number 1, the Pixel 11 Pro Vision. Let's look at the physical hardware foundation that makes on-device AI actually possible. Looking at the sheer scale of hardware upgrades in these leaks, it's pretty wild. The Pixel 11 Pro, which is currently codenamed Grizzly, is packing a custom Tensor G5 processor, and this thing is built on a highly efficient 2nm TSMC architecture. But honestly, the real star of the show here is the RAM. We're talking 16 gigabytes across the entire Pro lineup. Google is aggressively packing memory into these devices, and it's not so you can just leave 100 Chrome tabs open. That memory is a dedicated runway for running heavy, on-device AI inference without ever needing to ping the cloud.
And the physical vessel carrying all this new silicon, well, that's getting refined too. Case leaks from manufacturers are pointing to a flatter, wider, and way less protruding camera bar. We're also seeing reports of something called Project Toscana. This is an advanced under-display infrared face unlock system designed for much higher biometric security. So you're getting this sleek, refined flagship shell that's purposefully built to house a massive technological leap on the inside.
Moving one layer down in the stack, Android 17 software upgrades. Because all that powerful hardware is absolutely useless without an operating system acting as a strict traffic cop.
So the crucial point here is how Android 17 completely revamps resource management. In older versions of Android, background apps had a lot of flexibility, which, often led to nasty memory leaks. But Android 17, it introduces super strict app memory limits based on your total device RAM. If an app gets greedy and exceeds those limits, boom, it crashes. The OS is also introducing background audio hardening. That basically means background apps can't just steal your audio focus or mess with your volume unless they're actively visible on your screen. These strict guardrails are there for a reason. They prevent UI stuttering and reserve your precious power and memory for those heavy AI workloads.
Now, because Android 17 manages memory so aggressively behind the scenes, it unlocks some extreme multitasking capabilities for you on the front end. We're talking universal app bubbles, meaning literally any app can run as a floating window without the developers having to rewrite their code. We're also seeing interactive picture-in-picture for desktop modes and even a new 90:10 split-screen option. This OS is built to let you juggle 5 things at once, fully confident that the giant AI engine humming in the background won't suddenly crash your phone.
Layer 3, the LiteRT AI engine. So the hardware and the OS need a way to actually talk to the generative AI models. This brings us to the developer runtime layer. Enter LiteRT. You might remember it by its old name, TensorFlow Lite, but Google has evolved this into a massive, universal framework for on-device AI. Specifically, they've introduced LiteRT LM. This is a specialized orchestration layer built from the ground up to handle the very unique complexities of running large language models right there on the edge. It manages the whole shebang, from tokenization to memory buffers. Think of it as the high-performance bridge connecting state-of-the-art AI, like the Gemma 3 models, directly to that Tensor G6 chip inside the Pixel 11 Pro.
And here is where LiteRT LM does something truly brilliant. It uses a feature called session cloning. So imagine you're using your phone to live translate a conversation, and at the exact same time, you're asking a chatbot to summarize a document for you. Normally, that's a lot of computing. But instead of loading 2 separate massive AI models into the RAM and draining your battery, session cloning lets both of those features share the exact same foundational model weights. They literally share the same AI brain without having to reload anything. This effectively doubles the multitasking capacity of that 16 gigs of RAM we talked about earlier.
It's a real game changer.
Layer 4, shrinking AI with TurboQuant. Because even with 16 gigabytes of RAM, AI models are incredibly bulky. Let's look at how Google breaks through this mathematical memory bottleneck.
To wrap our heads around this, we have to talk about the key value cache, or KV cache. As an AI processes information, it creates a high-speed digital cheat sheet so it doesn't have to keep repeating the same massive calculations over and over. It is fantastic for speed. But this cache consumes terrifying amounts of memory, especially if you're having a really long back-and-forth conversation with the AI. It is basically the primary bottleneck for running AI on a phone.
And this brilliantly illustrates how they're fixing it. Through a brand new algorithm called TurboQuant, Google has managed to reduce the memory usage of that KV cache by a massive factor of 6. That means the AI can remember 6 times as much context without asking your phone for a single drop of extra physical RAM.
The math behind this is just fascinating. TurboQuant pulls this off in a two-stage process. First, an algorithm called PolarQuant takes all that complex AI data, the vectors, and converts them from a standard grid into polar coordinates. It shrinks them down to just a radius and an angle. It's essentially a highly compact shorthand. Then, just to fix any tiny accuracy drops from compressing it that much, a second stage called QGL applies a tiny 1-bit corrective layer. So it shrinks the data, keeps the model perfectly accurate, and allows the computations to run up to 8 times faster.
Finally, Layer 5, the Edge AI experience. We've got the 2-nanometer chip, the strict OS memory limits, LiteRT, and TurboQuant. Let's bring all the layers together. What does this full-stack integration actually mean for you, the user?
Well, it allows your phone to use what developers call the progressive disclosure pattern. Because your phone now has this incredibly efficient AI pipeline, it can run smaller agentic models that don't need to know how to do everything all at once. Instead, the AI figures out what you want, dynamically loads a very specific skill, maybe that's executing a JavaScript command or pulling a quick Wikipedia lookup via a tiny metadata file, and then executes it seamlessly. The AI essentially just grabs the exact tool it needs at the exact second it needs it, which keeps your memory totally free.
And the real-world benefits of this architecture? They're staggering, because all of this math and processing is happening directly on the edge, right there on your phone's Tensor G5 chip. You get zero latency execution, no waiting around for a cloud server to think. It guarantees total data privacy because your personal data never actually leaves your device. You even get offline function calling. And don't underestimate these tiny models. They are incredibly smart because they are fine-tuned using synthetic data generated by much larger cloud-based models.
All of this brings us to a foundational quote from a recent research synthesis on the topic: tiny language models and agentic systems at the edge. What we're witnessing right now isn't just an upgrade cycle, it's a fundamental architectural shift. The Pixel 11 Pro isn't just getting a slightly better camera or a brighter screen. Through this really deep integration of silicon, Android 17, and LiteRT, your phone is being transformed into a fully autonomous, agentic system.
And that leaves us with a pretty fascinating question to consider as this tech becomes reality. If your phone can truly reason, execute code, and load new skills autonomously, instantly, and completely privately without ever needing an internet connection, what autonomous tasks would you trust your fully on-device AI agent to handle for you? Take a moment to think about how that's going to change your everyday workflow. Thanks so much for joining me for this explainer, and keep learning.